Hey there, I'm Nix, and as a way to send off the Arrays 101 Explore card on LeetCode, we're going to be focusing on refactoring today. We're going to revisit a couple of the problems and tweak some of the code to improve it in places. If that sounds interesting to you, then stay tuned. First up is the duplicate zeros problem. Scroll down here, and there are a few tweaks to this problem that I want to go over. Essentially, removing a little bit of these extra if statements and condensing them down. As you can see here, this else statement and this if statement essentially have the same exact code within them. So here, what I want to do is, instead of having an extra condition here in this part, the count zeros equal to count zeros to dupe, I'm going to turn that into its opposite, so the count and the count zeros to dupe integers are not equal. Move that here, and then I can just eliminate this entire if statement altogether. So these are all the changes. Now, this if statement here, the count zeros, as I said, is changed to make sure it's not equal to the count zeros to dupe. And essentially, this means that that extra fourth if statement is eliminated, and this else condition is handling the non-border zeros and the zeros that are at the start that need to be duplicated instead of shifted. Now, I could also further condense these two lines, because again, this line is essentially the same as this line. It's just a little bit more specific. So I could have this condition in here as an OR. So it'll look for these three conditions to all be true, or it'll look for this condition to be true, and then it can execute this line, and then this further condenses these two. So as you see, you can combine them. This in the parentheses here are all the three conditions for the first situation, where it handles the starting zero by shifting, or you can also look to handle non-zeros by this condition. So if either these three conditions or this condition are true, then simply execute this line of code. So you can reduce the if statements, but if you do so with the non-zeros as well, this line tends to get a little long, as you can see. But it should still work. So let's see and verify that. This looks like this. Good. Now let's submit. And all we want to see is green text. So this is the first problem to tweak by eliminating some redundant code and some extra if statements that don't really need to be there. Looking at the rankings. Okay. Runtime here. Again, it probably ping-pongs around, but that's nice to see. And the memory usage is also very high. Okay. Very, very cool. So let's move on to the second problem. Second problem we're going to do a little tweak to is the merge sorted array problem. So scroll down here and you'll see the last code that I submitted. So this is all well and good, but I have a little bit of redundancy I can reduce. I can get rid of one of these else if statements because, again, looking at it, within these two else if branches, the code is exactly the same. So you can really condense these two conditions by, instead of being less than or equals, I can just simply say less than or equal. And then this one goes poof. And that one tweak will help reduce redundancy. And again, it should have no problems running. Shouldn't have any any red text anywhere. So this matches that. Great. Submit. Pending. Judging. And green text. Great! Let's look at its details just out of curiosity. And we're into here. Oh yeah, this was the one that only didn't really have much of a distribution for its distribution graph. And register the "you are here" sign. Okay, then let's move on. Next up is the valid mountain array. For this one, it's not so much a tweak as just something I want to mention because I can't remember whether I talked about it in the initial video in the first place. But this section here, where you're checking to see if the array size is less than 3, and if it is, just return false. That doesn't technically need to be there in order for the code to function. What it does is aid in optimizing things. If we were given, say, an array size of 2, it would have to go through all of the loops, and the loops would work, it's having to do a lot of steps when you could just say in one step, hey, is it less than a size of 3 for this array? And if it is, we automatically know we can return false. So it's a way to optimize things a little bit and avoid having to go through a bunch of extra steps just to automatically return false. But I can comment it out in its entirety, and you see I'm just going to run code just to prove that it works. See, false and false. If I just have an array that is equal to one thing and one thing only, it still passes. There's no there's no red text, there's no compiler errors, so with this commented out, it still works, but it's just better to have it there for some optimization purposes. Okay, the sort array by parity problem. This one I want to show an alternate way to do swapping that doesn't involve using a temporary holder variable. Now this will work well when you're swapping around numbers because you're doing it via adding and subtracting values. So this temp holder is going to go bye-bye, and this code I'm going to fiddle with to turn it from the temp holder way of swapping to the addition subtraction way of swapping. Okay? Here is the code to do swapping numbers by addition and subtraction. So here, this example, a starting index is initially 3, a end index is initially 4. So when this line executes, it will set a starting index to itself plus a end index. So 4 plus 3 will make a starting index now equal to 7. Now this line executes. It's going to set a end index equal to the starting index, which from the previous line now equals 7, and it's going to subtract from that number itself. So this is going to be equal to 7 minus 4, which is going to be 3. Now that you see it has swapped the end index with the start index, but our start index still has the combination of the two. So in order to fix that, the third line will now execute, and it will set a starting index equal to itself and then subtract the new end index. So this will be 7 minus 3, and a start will now change to 4. Let's see and run this code and make sure that it works. Judging, finished, 4, 2, 1, 3. And this is one of the few times where I don't have to care that this doesn't exactly match this, because all I care about are that the evens are up front and the odds are in the back, which this does. So when submitting, we should see green text, which we do. Great. So let's check out the details just for fun. Cool, right in the middle in the first distribution. Nice, and 93.87% of memory usage. Also nice. Next up is the problem that I had just completed a video on. Final numbers disappeared in an array. Now this one, I did mention the use of the absolute value method that is a part of C++, but I did everything just using raw code. I want to now show you how the algorithm can be condensed and look a little cleaner if you do use that method. First off, looking at this if statement and this else if statement, really the only difference between the two is if the value is starting out positive or the value is starting out negative. But if you use the absolute value, you don't really need to care about that in your use of your referencing. So here, here, and here, if you instead use absolute value of nums I, instead of just manually shifting it negative if the value is negative, then that will eliminate an entire else if statement here. And then you just need to check whether this is positive and you'll be golden. This is what you're left with. And so with this change, this should still work. Let's run code to make sure. Pending. Okay, no red text. This matches that. So submit, and more green. Yeah, more green text. Excellent. Looking at the more details just for interest. Okay, here you are here. I think that's where we are the same. So, and we're still, you are here. So a little tweak just to make it look a little cleaner and reduce an if check. Finally, let's get to our last problem. The squares of a sorted array. Now, this problem we did previously. Where was it? Here, in the introduction section. And we also, from the code here, we did it in an O of n solution. But what I want to do is I want to further optimize my memory usage. So instead of making the 3 vectors I created initially, I want to just make 1 vector and get this algorithm to work in an O of n way with just making 1 additional vector. How do I do that? Well, in this for loop, I was squaring the numbers and then pushing them into their positive and their negative squares. Well, that's no longer going to work. Now I want to go through the nums array and square every number I see. Now, this loop would just simply square all the numbers, but I have a few more tweaks to do for this for loop in order to make my algorithm still work. Now, because I'm doing this all within the original array, this original array is going to become this array. But the nice thing about having those other 2 vectors, the positives and the negatives, is it made getting the position indexes that I needed to have when starting the loop for the comparison purposes here very easy. I knew for the positive array I would want to start at its beginning, and I wanted the negative array index to start at its end because I essentially wanted to look at the smallest value that would be present in the negative array after the negatives are all squared. And I wanted to look at the smallest value in the positive array that's present after all of the positive numbers are squared. And in that case, that happens at this position here and this position here. Now, if these 2 things are separate, all of the positive values are here, so you start at the beginning. All of the negative numbers initially are, their squares are these. So this would have been the negative array. And you see at the end of that array is where the smallest values for those squares lie, because it's still ordered, but it's in reverse from what you want. So if you start at the end of the negative and the beginning of the positive, you're guaranteed to see the smallest values, and then you just loop in reverse for the negative array and loop forward for the positive array. But now that I'm doing this in all one array, that's no longer possible. So I need a way to make sure I start at the appropriate indexes within the nums array now. And I can do that via a tweak to this for loop. Okay, these are the tweaks I did. So here I just moved the integer in front of the for loop because I'm going to make use of it, and it's set to 0. Now within this for loop, I'm going to run an if check. And if the number I'm looking at is less than 0, then I want to increment up that positive array index. So it's going to start at the beginning here. See, this is a negative number. Going to increment it up by 1, loops around again after it squares it. It sees initially, oh, well, this is a negative number again, and I'm going to increment it up again. Squares it, loops back again. Now the moment it doesn't see something that is negative, it stops incrementing this index. So at the end of this for loop, this index position is going to be exactly where I want it to be. Essentially, at the smallest value that the positive numbers have when squared, which in this case is 0 at the index value of 2. Now that I know where that position is, I also know where this negative array index is going to be. This negative array index is essentially going to be located one position down from where my positive array index is. So instead of referencing a non-existent array here, I just want to reference my positive array index and subtract 1 from it. And with those two positions, I can now complete these while loops just within the nums array. The only thing I need to do here is eliminate all of the references of the positive squares and the negative squares and just reference nums instead. So with that, this entire algorithm should work now with just needing to create one vector. So let's see if it does. Judging, this matches that. That's good. Let's see if I have green text. Come on, give me green. Yeah! Accepted. Perfect. All right, and as an additional note, you see that this was an orange check mark because I had technically completed this problem in the previous section up above, but I hadn't specifically pressed the submit button in this problem here in the conclusion section. But now that I did, it changed from orange to blue. And with that, we can see more details here, where our distribution is around the same area. Again, ping-ponging happens. And memory usage is right around here. Okay, cool. And with that alteration to the squares of the sorted array, which is the last problem here, well, that I can actually do since I don't have premium, the Arrays 101 Explore card is complete, and the next thing I'm going to do is probably going to the Arrays and Strings Explore card, since that's probably the next logical step to do it, because lots of tech interviews like to ask about arrays and strings. So that's the plan, and if you're curious about the details of solving any of these problems here that I'm showing off, then you can check out the Arrays 101's playlists that I've completed, and hopefully that shows up on your screen right now. Alright, with that said, I wish you happy coding and to have a nice day.